Hi, this is Miss Moreland. Welcome to 8.5, and this one's going to be factoring special products. So really, it's nothing new, but you're going to want to learn some shortcuts so you can factor some things quickly. So we're going to start by just reviewing a couple things. So perfect square trinomials and difference of two squares you've heard before. So this is going to actually be a perfect square trinomial. You should know how to multiply this, so I want you to pause the video and go ahead and multiply it. Just remember that when squared really just means you write it out. Now you can use the box if you want, or you can use the FOIL method. I'm going to use the box for the first one and FOIL for the second. So go ahead and get these done and just fast forward to check your answer if you're confident. If you didn't get it right, go back just to recall how to multiply. So you should get x squared, 4x, 4x, and 16. So you should get x squared plus 8x plus 16. If I multiply this one out, again, squared just means write it twice. I get x squared minus 7x minus another 7x plus 49. So my final answer is x squared minus 14x plus 49. Now I want you to look at for a pattern here real quick. So this one had a 4. 2 times 4 is 8, and 4 squared is 16. So the middle term is really 2 times 4. And this is really, oops. And 16 is really 4 squared. Same with this one. This one was, middle term was negative 7. This is really 2 times negative 7, and 49 is really negative 7 squared. So we're going to look at these and see if we can factor them. So what I want you to do is pause the video and use your diamonds or x's to factor these. So you're going to multiply to 36, add to 12. It's going to be 6 and 6. So you get x plus 6 times x plus 6 for your factoring, which is equivalent to x plus 6 squared. Now I hope that you're looking at this and thinking, this one's probably going to be something squared too. You're going to multiply to a positive 1, add to a negative 2. The only factors of 1 are 1 and 1. But if you want to add to a negative, you need to make both of your factors negative because I still want to multiply to that positive 1. So this one is x times x minus 1 times x minus 1, which is equivalent to x minus 1 squared. Now this one's a little tricky. I'm going to do it the long way first, and then the second one I'm going to do is the short way. So this one, remember, you have to do factor by grouping, so you multiply the first and the last. You get 36. You're trying to multiply to 12 still. So you get 6 and 6, but your answer, unlike the top one, is not x plus 6 squared because you have this number in front. So remember, you split up the middle term. So you get 6x plus 6x. Last term stays the same. First term stays the same. Oops, I forgot the plus sign. And then you group them. So you're left with the front, you can pull out a 3x. So you're left with 3x plus 2. Second one, 6x and 4 just have a 2 in common. So I'm left with 3x plus 2. Notice that I still get two of the same things here. When I go to factor my parentheses out, I have 3x plus 2 inside parentheses. And once I get rid of those, I write the leftovers, which is 3x plus 2 again. Oops, ignore that line there that I wrote. Which is still equivalent to 3x plus 2 squared. Now I want to look at this one real quick just so you can see where I get the 3x from. 9x is just the same as 3x times 3x. And 4 is the same as 2 times 2. So I get 3x plus 2 squared. So 4x squared is 2x times 2x. And 9 is 3 times 3. So if I were to factor this, I'm going to get 2x plus 3 squared. So that's really the shortcut. So what you want to look at, these are all called perfect square trinomials. The first and the last terms have to be perfect squares. And what it means to be a perfect square is you can take the square root of it. So for example, some perfect squares are 1, 4, 9, 16, 25, and these are all perfect squares because 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared. So if you want to find all the perfect squares, you're just going to continue listing those. So the first terms, for example, this perfect square is just x times x. The last term is this perfect square, 6 times 6. To get the middle term here, it's really 2 times your first and your last. So it's really 2 times x times 6, which gives you 12x. So this would just factor to x plus 6 squared like we already saw, and we should know that once we get more used to these examples. This next one, it's 2x and 2x. And the last one is 3 times 3. Again, to get the middle, you do 2 times your first and your last factors. So it's 2 times the 2x times 3, which will give you 12x again. Again, to factor this, it's really just going to be the first perfect square and the last perfect square. Now, it's not always going to be a plus here. It depends on what sign this is. So if this is a plus, it's going to be a plus in your factored form. If this is a negative, it's going to be a negative. Okay? So as we talked about before, you're going to want to start looking for these perfect squares. So 2 squared, 3 squared is 9, 16, 25, 36, 49, and you could continue those on. I would suggest you go all the way up to 15. Oh, too far. 8 is 64, 9 is 81, and 10 is 100. Some of these you may need to practice as you get farther up. And 15 squared is. So I would start looking for some of those. I would not think that it's going to go all the way up to that, but so this is already on your note sheet. I want you to look at this. So again, the first term has to be a perfect square, the last term has to be a perfect square. And to get the middle one, you take 2 times 1 of the first times 1 of the second. And remember, this sign right here is what dictates what's going to be your factored form. All right, so we're going to use the shortcut to factor 2 of these. So x squared is just x times x. 4 is 2 times 2. The middle term, remember, is 2 times x times 2, which gives you 4x. Factored form is you take your first perfect square, which is x, your last perfect square, which is 2. You take this sign here, which is positive, and your factored form is just x plus 2 squared. All right, I want you to pause the video and see if you can get this next one what the factored form would be, or see if you can even just jot down what you think it would be. So you should be thinking that since 4x is 2x times 2x, and 25 is 5 times 5, you should be thinking that it's 2x plus 5 squared, and it's plus because this is a positive here. Just check your middle term, so it should be 2 times 2x times 5, which gives you a 20x, so that is your perfect square. Now we're going to move on to a difference of 2 squares, which I tend to find easier because you don't have to deal with that 2 times the middle term. So quickly multiply these out. So I'm just going to give you the answer. It's x squared minus 9. That's what that looks like multiplied out. And this is x squared minus 25. Notice that since you have opposite signs here, your middle term cancels. Okay, so I'm going to factor one of these, the longer way, not the long way necessarily, and then I'm going to show you how you can quickly do the other one. Alright, just forget that. So if you end up and you forget the shortcut, let's say on a test, you can always put a 0x in the middle and draw your x. So I'm going to do this one the long way. I'm trying to multiply to a negative 16, trying to add to 0. So I should be thinking, 4 and 4 multiplies 16. If I want to multiply to a negative, I need to make one of them negative. Is negative 4 plus 4 0? Sure it is. So my answer is going to be x minus 4, x plus 4. So that was pretty quick to factor even without knowing a shortcut. So if you look at this, this is really x times x in the beginning, and 16 is really 4 times negative 4. So if I look at this one, this is a perfect square of 2x times 2x. 25 is the same thing as negative 5 times positive 5. So the factored form of this, without having to do any diamond or anything, is 2x minus 5 times 2x plus 5. Notice that these always need to be opposite signs to get something that has a middle term that would cancel. So the shortcut for this is the first and last terms are perfect squares, and the key is they have to be separated by subtraction sign. So x squared minus 4 can be factored to x minus 2, x plus 2, because x squared is x times x, whoopsie, and negative 4 is negative 2 times positive 2. So pause the video and see if you can factor this one. I find this, the difference of 2 squares, easier than the perfect square trinomial. So 4x squared is 2x times 2x. I keep writing an extra line. And 9 is 3 times negative 3. So it's going to factor to 2x plus 3 times 2x minus 3. And again, if you're ever wondering if you got the rule right, it's probably beneficial to FOIL it out. So you get 4x squared minus 6x, and then you get plus 6x minus 9. Notice that the positive 6x and the negative 6x cancel, so I've checked it with that answer. So this is already in your, oops, somehow my slide went somewhere. This is already in your notes. Notice the key is for this, they need to be separated by a subtraction sign, and they both just need to be perfect squares. So here's one example that we just did. They need to be opposite signs when you factor. Opposite signs when you factor. It's really the only thing for difference of two squares. So see if without using the diamond or the x and putting a 0x, if you can factor this just quickly. So you should be thinking x squared is x times x, and negative 1 is 1 times negative 1. So you get x plus 1, x minus 1. Notice that this only works if there's a subtraction sign and there's no middle term. And they both have to be perfect squares. So 9x squared is 3x and 3x. Negative 4 is negative 2 times positive 2. So this is going to factor to 3x minus 2 and 3x plus 2. Right, we have one more here, and I just want to show you that even if it's not a squared here, they can sometimes be perfect squares. So p to the 8th is really p to the 4th times p to the 4th, because remember when you multiply, you add the exponents, and 4 plus 4 gives me 8. There is a subtraction sign, so it works. 49 is 7 times 7, and q squared is q times q. So 7q times 7q would give me 49q squared. So this is equivalent to p to the 4th minus 7q, and p to the 4th plus 7q. Okay? All right, go ahead and try the on your own tonight for homework, and I will see you tomorrow.